Okay, so here we have a improper integral, and we're integrating this from infinity to 2. We have to indicate whether this is a convergent or divergent integral, and we have to also, if it's convergent, we have to find the area. So let me write this as a limit. So this is going to be the limit as b approaches infinity, integral b to, and then y e to the negative 3y dy. So this is going to be, we have to first find the antiderivative of y e to the negative 3y dy. So this is something that's going to be using integration by parts, IBP. Because if we set u equal to y, that's not going to help. If we set u equal to negative 3y, that's also not going to be helpful. So u substitution is not the way to go for this one. This is integration by parts. So I'll set u equal to y, du equal to dy, dv equal to e to the negative 3y dy. So v is equal to the integral of this, and I think this is going to be 1/3 e to the negative 3y plus c, which we don't need, plus c. We can double check that. So this is just going to be integral e to the negative 3y dy. This is equal to, if I set u equal to e to the negative 3y, negative 3y du is equal to negative 3. Negative 3 dy is du, and this just becomes the negative 1/3 integral e to the u. So this is negative 1/3 e to the negative 3y. So I forgot a negative here. I should have included a negative. And that makes sense because it's negative 3y, right? So if this was e to the 3y, then that would be just 1/3 e to the 3y. Okay. Plus c. We needed the plus c, but we don't need the plus c for integration by parts, so that's fine. Okay. This is just going to be equal to then y times negative 1/3 e to the negative 3y subtracted by integral v du is negative 1/3. So we can multiply, we can add this, make this positive 1/3 because we move the negative 1/3 outside, making this e to the negative 3y dy. We know what this is, right? E to the negative 3y. That's just negative 1/3 e to the negative 3y. So this stuff is going to be, so let me rewrite this. So this is just going to be y times negative 1/3 e to the negative 3y, and then plus 1/3 times negative 1/3 e to the negative 3y plus c. So this ends up being negative 1/3 times y times e to the negative 3y minus 1/9 times e to the negative 3y. Okay. Yeah, this is just negative y by 3 times e to the negative 3y minus 1/9 e to the negative 3y plus c. So this is equal to, let me write this as a limit as b approaches to infinity. And then this just becomes negative y. What we can do is we can actually combine these two, right? So let's just make this negative y by 3 minus 1 by 9, multiply 3, negative y by 9 minus 1/9, negative 3y by 9, right? Negative 3y by 9 minus 1/9 is negative 3y minus 1 by 9. Let me double check that I didn't make any mistakes. So negative y by 3 minus 1 by 9 is negative 3y by 9 minus, yeah, this is right. So this can be written as negative 3y minus 1 by 9 evaluate at b and at 2. So we're still in the y world, so we have the same bounds of integration here. Okay, so this ends up being the limit as b approaches infinity, and then negative 3b minus 1 by 9. Okay, and I forgot to add the e to the negative 3y here. This is a very stupid mistake. Times e to the negative 3y. We should add that. B to, so yeah, negative 3b minus 1 by 9. And then times e to the negative 3b minus negative 3 times 2. So negative 3 times 2 minus 1. So negative 3 times 2 is negative 6 minus 1 is negative 7 by 9. And then times e to the negative 6. Okay, that's that. So this becomes the limit as b approaches to infinity. Let me split this up here. So negative, actually let's write it as 1. Negative 3b minus 1 by 9, and then actually let me write this as e to the 3b instead of making it a negative. Okay, and then plus 7 by 9 e to the 6th power. This is just going to be equal to, so as b approaches to infinity, this stuff is actually just going to be, so infinity, and then as this goes to infinity, the whole denominator is going to get larger and larger and larger at a faster rate than the numerator. Even the numerator is going to get larger and larger and larger in the negative way, in the negative direction, so negative infinity. But then this one's going to get larger and larger and larger at a faster rate. So this ends up just being 0. And then plus 7 by 9 e to the 6th power, which is just 7 by 9 e to the 6th power. That's actually our answer. It's kind of a weird answer, but this is actually our area. And just to reiterate, here if we look at the limit as b approaches infinity, b is going to infinity, this is going to go to negative infinity, but this is going to go to positive infinity. But since we have an exponential, it's going to go faster to positive infinity than this is going to go to negative infinity, so this is getting larger at a faster rate, which means the denominator is getting larger at a faster rate. It's going to approach to 0. It's not negative 0 because it's just 0. So it's 0 and then plus 7 by 9 e to the 6th power is 7 by 9 e to the 6th power. So this just ends up being convergent. This was an interesting problem. It involved the use of the integration by parts formula, integration by parts, and just proper, limits and understanding limits as well. Hope you found this video helpful.